Alright, so let's talk about how we would find the derivative of this implicitly defined function. That is, we're looking for, on that circle, we're looking for the slope of the tangent line to that circle at any particular point. And dy dx is the slope of the tangent line. It's the rate of change of y with respect to x. Alright, so you can see over here that I've started by placing the original expression x squared plus y squared equals 1. Then I solve for y, and I get y is equal to plus or minus square root of 1 minus x squared. If I wanted to find the derivative of that, then dy dx would equal, leave the plus or minus there, and instead of looking at this expression in radical form, we'll write that in a rational exponent form. And then we can use the power rule to find the derivative. So the plus or minus we leave out there. We'll get 1/2 times the quantity 1 minus x squared. Then reduce the original 1/2 by 1, so that'll be negative 1/2. And that's the derivative of the outside function, which is the square root function. Then we need to multiply that by the derivative of the inside function, which is negative 2x. And at that point we're done. Now we could simplify this a little bit. Now with all the plus and minus and the signs in there, it's going to be a little bit more complicated. But what I would do first is possibly cancel the 2's. And I would have negative x over 1 minus x squared to the 1/2. And plus or minus that. Now, again, I'm trying to get this into the form that I found in the previous video. That was just a simple dy dx is equal to negative x over y. But if you recall above that y is equal to plus or minus the square root of 1 minus x squared. So that whole thing might be able to be rewritten in this form. And since plus or minus square root of 1 minus x squared is y, then I can swap out that. And I get the form that I found using geometric or trigonometric properties in the previous videos. So what I do want to note here, though, is that this is how we have done things in the past. From this point on, we're going to do things like this. We're going to add a different strategy. This problem could be solved two different ways, but some problems cannot be solved for y, and so we're going to have to use a separate strategy, and this is how it's going to work. We'll come over to the second, to the right side of the screen here. Alright, so we're starting with x squared plus y squared equals 1. Well, what I want to do is take the derivative of both sides with respect to x. And so I have the derivative with respect to x of the quantity x squared plus y squared is equal to the derivative with respect to x of 1. Now, when we're taking derivatives with respect to x of any term that's written in terms of x, that's easy to do. So first of all, on the left side of the equal sign, we know that we're working with a sum, so we're going to use the sum and difference rule here. So we want to split this up, and we know that the derivative with respect to x of x squared is just 2x. Now, when we have a difference between the variable in the expression that we're trying to find the derivative of and the variable that we are finding the derivative with respect to, that is, when that x and that y don't match, we can't just use the straightforward power rule. We do use it, but we treat it like a chain rule. So we took the derivative of y, which is 2y. Now we're going to assume that y is a function of x. And we're going to assume that this is just like a chain rule, and after we take the derivative of the outside function, we're going to find the derivative of the inside function. So we get 2y dy dx, and the derivative with respect to x of 1 is 0. And from this point, you simply solve for dy dx, which we'll do in the next video.